Good morning and welcome to the second day of learning biology from your teacher at home. Um, Thank you for your patience with me yesterday as I had to have emergency sub plans and had to kind of go off track for a day. I hope to be back on track today. I heard some pretty daunting reports of attendance in my classes yesterday. So I imagine that I know that most of you are at home learning, and I would imagine that some of you who really are allowed to go to school, that your parents may choose not to send you, and that you may be learning from home as well today. Either way, you guys are going to be getting the same lesson. If you're in class, then I will have a sub. I'm scheduled to have Mr. Hunt, and he will be opening my Canvas page for today and taking you through the different assignments and steps that I have listed there for today, which will be the same assignment and the same steps that my online learners will be going through. So hopefully it will all work out. I've tried really hard to make it run smoothly, but you never know. Wanted to make a couple announcements. One is that you do have a quiz tomorrow on mitosis, and not just mitosis, but the cell cycle, and also what is, like a chromosome and what's a gene and what's haploid number and diploid number, those two sets of notes. The objectives are 5.01 to 5.11. They should be on the board. The quiz, you will have access to your notes and your book, because I can't really keep you from accessing that when you're taking a quiz at home. And because I can't do that for my online learners, I would not restrict my in-class learners from being able to have access to that. However, I will tell you that once you start the quiz, it will be timed. So there will be a point when the quiz will be done and your answers are either filled in or they're not. So it's helpful for you to have studied and know the information in advance. So it's really not designed to be an open notes, open book quiz, but you will have access to that. So if you take advantage of that and you have time to take advantage of that, that's fine. Just don't count on having time to take advantage of being able to look through your notes and your book for every answer to every question. I think you should study as if it were going to be closed notes and closed book is what I'm saying. Okay, let's see what else. We have really pretty much wrapped up mitosis, and I want to start going through meiosis. Mitosis is how cells make exact copies of themselves, like if they want to replace worn or dead cells, like our skin cells are always making copies of themselves and they want to make exact copies of themselves. If you need to repair tissue that's been cut or something like that, or if you're growing from your first single cell, the zygote, all the way up into adulthood, then new cells have to be made. That type of cell division, called mitotic cell division, is also useful for asexual reproduction in like single-celled organisms like an amoeba and stuff like that. So we've really kind of covered that, and we're ready to talk about the second sort of cell division, which is meiosis. And meiosis is the type of division of chromosomes after they're copied. So you copy the chromosomes and then you divide them up in such a way where what's formed at the end are not exact clones of the parent cell, but are cells that are gametes. So meiosis is used to form gametes, special haploid cells that are used in reproduction. And so that's what we're going to start talking about today. I'm going to show you a video from the publishers of your textbook where one of their teachers takes you through the steps of meiosis as they're explained in your textbook. I'm going to have you watch a video from a different teacher who's modeling meiosis out for you, sort of like we did with Play-Doh. And then you'll have some review work. And so you'll just kind of go step by step through the module for today on Canvas, and hopefully it will flow. For the second half of the class, I'm going to ask your sub to Zoom in, and I will also obviously be on the Zoom meeting. So anyone at home who would like to Zoom in and get extra help or ask any questions that you want to ask about what we'll be learning today or about what might be on your quiz for tomorrow, then you will be able to Zoom in. So pretty much the whole second half of the class, I will be available on Zoom for anyone to join that meeting and talk to me about whatever you need to. That will be the time when you guys are doing sort of like your in-class work. Okay, I think that's all I need to say, except that I wanted just to talk to you for just a minute about mitosis, because when we modeled mitosis with Play-Doh, we did it in such a way that we used like 2 colors, remember? And like one pair of chromosomes, we made one color, like 2 short blue ones, and then another pair of chromosomes we made longer and we made them another color, like 2 long yellow ones. And then we took them through the steps of mitosis that way. If I were to show you a drawing of what we modeled, like with the Play-Doh, then it would look something like this. So you notice that it says how we modeled with Play-Doh. This is mitosis, and it's taking you through the steps of mitosis. And what I want you to see is this is how we did it, where one pair of chromosomes was one color and the other was the other color. And so for that one pair, the shorter pair, then one of them would be the one from the mom, the other one would be from the one from the dad, and we called them M2D2. And for the first pair, we called them M1D1 and took them through the steps. So this is a great way to model mitosis, but it's a little different than the way meiosis is often modeled. And so I just wanted to show you what mitosis would look like if we use the same sort of color scheme that is usually used for meiosis. So that's what I show you here. So this is another way of looking at the same thing, but in this case, instead of having like each member of the pair be the same color, so we wouldn't have like 2 short, what color were they? Green ones and 2 long purple ones. We would have a short pair and a long pair, and one member of the short pair would be pink to indicate that it came from the mom, and one would be blue to indicate that it came from the dad. And one member of the long pair would be pink, and one member of the long pair would be blue to indicate that one came from the mom and one came from the dad. And this kind of eliminates the need to label the chromosomes M and D, mom and dad, because we know that the pink chromosomes originally came from mom and the blue chromosomes really originally came from dad. And the only reason I bring that up here is I just wanted you to have that for reference, and these papers will be on Canvas for you to look at through this video anytime you like, just to help remind you like how the videos can be colored, how the chromosomes can be colored, because in meiosis, we usually start this way, where we use pink and blue to designate the chromosomes that are from the mom and the dad rather than M's and D's. And so I just didn't want you to get confused. I think that's all. And hope I didn't confuse you with that, but I think that might make sense to you more later as you watch the meiosis video and you wonder why they're modeling with like mixed colors within a pair when we modeled with a pair of homologous chromosomes being the same color. So I just didn't want you to get tripped up by that. All right, I think that's it. Like I said, I'll be zooming in with you later, and see you soon. Bye-bye.